Okay, so let's take a look at this warm-up here. So you are explaining what this information means for each of these expressions here. We have 1, 2, 3, 4, 5. So let's take a look at the first one here. So this log base 0.65 of 0.5 to equal 1.61. This is saying that it decays 35% annually, means it will take 1.61 years to drop to that 50%. So it decays 35% annually, so it takes 1.61 years to drop to 50%. Now, I'm doing the natural log of 0.5 over the 1.61 years to get this answer here, which is our K value for decaying 35%. Then the next one down below is E raised to that K value to equal 0.65. So that's the same thing as saying 65% is left after 1 year. Then the next one, E, same thing, timesing it by 3 for the time there. So after 3 years of losing 65% per year, we drop to 27.5%. And the last one here, 200 times, again, E to the constant, this time times 4 years. So we have initial amount of 200, decaying 35% per year will drop to 35.7 after 4 years. So on the next slide, it has it detailed out the answers, what I just talked about here. So it's leading from one thing to another. Then it asks you to evaluate e squared and e to the third into your calculator and write it down for 5 decimal places. So hopefully you guys got these 3 answers. Okay, so today's objective is we're going to be taking a look at the e function and what is its derivative. So let's take a look at these examples here. Go ahead, what's happening, you can either do this in Desmos or on the calculator. Desmos is just a lot easier. See what you get for your answers here. Okay, these are the answers I got when I plugged it in Desmos. I'd like you again to try this again. Now for this next set, e to the first minus that. Go ahead, try those. Come back to see if they have the right answer. These are the answers I got for that one there. And then lastly, let's do e to the 3.5. Again, when you're done with this round, go back and look at the numbers you wrote down in the anti-set, and you should notice something, hopefully. So if you notice, with these answers, we're doing that average rate of change, right? Slope here for E. And they are all converging towards those same values that we figured out for e to the first, e to the second, and e to the third. And then here I have some graphs here on the right side showing us the e function with the tangent line, instantaneous slope. So basically, what are we doing? We're doing instantaneous slope. Remember this from limits from last semester? So the limit as it goes towards c of the function minus f of c over x minus c. So here, if I do each of these e functions, e to the first, e to the second, and e to the third, that average rate of change, which is that limit value, comes back to its original function. So here, e is its own derivative. So if I have e to the fifth, and I want to find f of 5, it's the same thing as doing it for the derivative of 5. If I wanted to find e to the 8th, f of 8, it's the same thing as doing the derivative of that function at 8 also. How fast it's growing is exactly equal to how big it is. If the function is equal to 10, then the slope is also equal to 10. So for the e squared graph, at x equals 2, the function is equal to about 7.389, and the slope of the tangent line is also, it should say, 7.389. Okay, there is a link on the Google thing that I have here. You could click on the link to see it, but I have a little snipping tool screenshot of it. So if I take any value of e to whatever x value in the derivative, it's basically the same thing, showing it there. All right, we could also do this on the TI calculator. Let's say I wanted to figure out what is the derivative of something of e now to the 5x. How can we check? So on the calculator here, I am graphing e to the 5x. And then to get this d over dx, so you're going to go to get this d over dx, you're going to press the alpha key, the window button, which will then pop up these couple of things right on the screen there. And you want to go to number 3, which is the derivative. Click on it, and your d over dx should come. I did not do the y1. I took this and I plugged in e to the 5x. You could if you want to do y1. I just plugged in e to the 5x. All my x is going towards x. Now I need to see the table. So how do I go to the table? Let's quit out. You're going to press second, table set, second, and then table set, which is the window button. And you want to set it where the independent variable you're going to ask. Enter on there. Dependent should be auto, so it gives you the answer. So I'm doing second table set. My independent, I'm going to ask dependent auto. So now go back out and press second table, which is second graph. And I want you to plug in 0.1, enter. And it should give you the answers that are right here. 0.5, enter. 1, enter. And then 2, enter. What do you notice about these values for y1 and y2 for the output? Well, it's looking like the slope is 5 times the output. So the derivative for e to the 5x is 5 times e to the 5x. So there is a formula here, which is something called the chain rule, which you're going to be learning more as you go into AP Calc classes. Here we're just introducing it, involving e. So if I have e to some exponent here, to get the derivative, I'm doing the derivative of the exponent times e to that same exponent there. So let's take a look at this one here. If I have my function as e to the x cubed, the derivative is going to be the derivative of the exponent. So how do I get the derivative of x cubed? Well, I'm going to do my power rule here, 3x to the second. So 3x squared times e to the x cubed. Same thing what we just did before for this one. E to the 5x, the derivative is going to be the derivative of the exponent. So the derivative of 5x is just 5. So it's 5 times e to the 5x. Again, as you go more next year into this, you're going to be learning more. So let's just take a look at this example here. This is from a BC Calculus study guide question. It says here, the rate at which water is leaking out of a tank is proportional to the amount of water in the tank. There are 400 gallons of water initially, 300 gallons of water at time 30 minutes. How much water is in the tank at 45 minutes? So we're going to work backwards, and we're going to get this poke model. So we're going to do 400 is the initial amount, E times the time, 30 times we don't know the K, to equal 300 left in the tank. So now let's get that K. So divide by 400 on both sides here. And we're getting it to be 0.75. E to that. Oops, let's change this thing here. Move it over a little bit. There we go. Sorry about that. Now we're going to go ahead and do what we did before. Change that to the log form. So natural log. E is the base. 0.75 is the answer times the equaling the power. K times 30. Divide 30 over. I get my K to be this. So now in my poke model, it's going to be 400 E times negative 0.00959 times time. So what we basically just did here, I want you to think about it, is we took this and we did the derivative of this power, which was just this in front, times 400 e raised to that power. So the function and the derivative are almost exactly the same. They're proportional with a constant of k, which in this case is at negative 0.00959. Don't stress too much about this. All you need to be able to do is find the derivative of these e functions, doing what that formula said from this previous page. All right, once you're done with this now, I'd like you all to then go back to your problem set, number 2, from Unit 5. Again, see what is left of your questions, answer keys on Google Classroom, and then we'll be continuing next week with some more.